Hey math kids, today we're going to talk about the multiplication rule of probability. We're in section 4.BC, and we're just going to start off with a example. So students in a science class are collecting weather data. They find that it is windy 50% of the time and cloudy 40% of the time. Furthermore, they note that half of the windy days are cloudy. Okay, what is the probability of a given cloudy day being windy? Okay, so the best way to approach this, I think, would be to do a Venn diagram. So we have windy, we have cloudy. Now, half of the windy days, so if we're only looking at this circle, half of the windy days are cloudy. So we know 50%, so that means 0.25 is there, and 0.25 is here, because half would also be cloudy, and then we have to make this circle add up to 50%. Now, we look at this 40% or 0.4, and we need the rest of this to jump up. So this entire circle is 0.4. We would add 0.15. 0.15 plus 0.25 would be 0.40. Okay, so now that we have our Venn diagram, I'm going to read the question again that I asked. So what is the probability of a given cloudy day being windy? So now we're only focusing on the cloudy days. So that's like 100% of what we're looking at. So if we know that we're cloudy, what is the percent that it's also windy? So once again, we're just going back to the what you want divided by the total. So 0.25 divided by the total, which is 0.40, because the total cloudy is 0.4, and 0.25 is windy when we're in that context. And so we just need to come to our calculator. And we do 0.25 divided by 0.4. We get 0.625. Or if we change that into a percent, you get that, or you could even round it to 63%. Okay. Now we're going to move on to the next one. This one says Rebbe chooses 10 numbers by rolling a 20-sided dice. Until 10 distinct numbers are rolled. If the probability that the numbers 1, 2, and 3 are rolled is P, so P is the probability of rolling 1, 2, and 3 as our distinct numbers. And if the probability of 4 and 5 are rolled, we call Q. What is the probability that Rebbe rolls 1, 2, 3, 4, and 5? Well, all we have to do is, if we want the probability of this to occur and the probability of this to occur, the overall probability is just going to be P times Q. Okay? Let's see. Let's move on to one more. So we're given a table. So this is likes dogs. This is dislikes dogs. Likes pigs. dislikes pigs. Okay, so we have this data. I'll just make this up. Okay, let's say we ask people whether they like dogs or pigs. If they like both, it would be this 10 people. If they dislike both, it'd be these 5. And if they like one or the other, it's the other one's represented. Okay, so given the following table, find the probability that a randomly chosen student will be both interested or will like dogs and also like pigs. So the place that represents someone who likes both is that 10. So 10 is what we want, and then we're going to divide that by the total. So 10 plus 3 plus 5 plus 12. Okay, so we got 10, and that's going to be 8, 9, 10, 20, 30. 10 divided by 30 is 1/3, which would be about 33%. Okay. And I think that's everything you need. So if you need additional help, please come to Math Lab. Until then, calculator.